said 16?
Yes.
Okay.
Yes.
So I have to find f prime of 20. I know f and g are inverses, so I would just like to get all into the same letter first of all. So I'm going to find g inverse prime of 20. And that's going to be 1 over g prime of g inverse of 20. So the first thing I have to do is figure out what is g inverse of 20. So if I said g of 20, you would plug in for the x, right? G inverse of 20, you're going to plug in for the y. So I'm putting 20 here. So x to the third minus 7. So 27 is x cubed, and then x equals 3. Fair enough there? So then if I just kind of forget this is just like blank space. So then if I keep going, that's 1 over g prime of, well, I just found that. G inverse of 20 is 3. So it's 1 over whatever g prime of 3 is. And they didn't tell me g prime, but they gave me enough for me to find it. So g prime is 3x squared. And then I just plug the 3 into the 3x squared. So like 3 squared is 9 times 3, so 27. Is it 1 over 27? Does that make sense, Max?
Yep.
Sure. Other ones?
Yeah.
15. Can I erase the stuff for 16? So again, like I know f and g are inverses, and they give me a g, so let's just like make everything a g. So this is g inverse prime of 4 that I'm looking for. So that's 1 over g prime of g inverse of 4. So my job is to find g inverse of 4. Again, if I were finding g of 4, I'd plug in 4 for x. If I'm finding g inverse, so I'm going to plug in 4 for y. So it goes here. So 4 equals root 8 minus 2x. I got to solve for x, so I'm going to square both sides to get rid of that root. So 16 equals 8 minus 2x. And then I can like subtract 8 and divide, and I'll get negative 4. That's just like the first one. That's the g inverse. So now I really have 1 over g prime of negative 4. So then we got to find g prime. So g of x is 8 minus 2x to the 1 half. So the derivative, bring down the 1 half, 8 minus 2x, reduce the power by 1, and then don't forget the chain rule piece, so multiply by the derivative of the inside. I wonder if that's maybe, it's so easy to forget chain rule as you go through these. And your job is just to plug in 4, so there's no benefit to simplifying. Let's just plug in negative 4 right now. Because if we're simplifying, we're just wasting time, and we might screw it up. So I'm plugging negative 4 there. So that's 8 plus 8, that's 16. Well, what's 16 to the 1 half? It's 4, and the negative 1 half. You flip it, right? So it's 1/4 times that negative 2. So it should be negative 1/4. Alright. Looking at questions or something like this. You're just processing. Very good. You don't seem to. Yeah, go ahead. one over when I was doing all that crap. Yeah, thank you. You knew that right away. You just weren't sure enough to say it. You were like debating.
I didn't write down the answer. I was like, sure it was not.
Okay. Yeah, no, you're right. Other questions? What? 13?
I saw that. I was like, what? What's this stuff?
You're right, man. That's how I hate it. Elliot's not. Is anybody, like, can anybody text Elliot? Well,
Yeah. Actually, it's true. Forgot that.
I don't have the money anymore.
can you tell him if he doesn't reply to my Haynes email?
Hey, so
He's gonna throw his glasses.
Gateways that
He'd be like, oh, cool.
I don't need those.
Is that what it's for, right? Online class. Online class. Not doing it. Online class.
he sent me a picture of his chalkboard and videos about trombones and French horns and memes. Those are scary memes.
13. I need to find f prime of the number 3 pi squared over 4. But all the stuff they gave me is g's, so I'm going to look at that as a g also. So f is not f. It's g inverse prime of 3 pi squared over 4 that I want. So g inverse prime is 1 over g prime of g inverse of the 3 pi squared over 4. So that's just like set up the formula. If I were to ask you to find g of 3 pi squared over 4, you would tell me, you would plug in 3 pi squared over 4 for x. I'm not. I'm asking you to find g inverse. So you plug 3 pi squared over 4 in for y. So this is telling me a point that's like pi over 2 comma 3 pi squared over 4. So it's x comma y, but when you inverse it, this is your x and this is your y. So I get pi over 2. Just because I read it backwards when I'm doing inverses. So my job is to take the derivative and then plug in pi over 2. And then I can't forget to put 1 over it, because I forgot that last time. So g prime, remember if it starts with a c, your derivative is negative. So negative sine of x plus, there we just get 6x. So g prime of pi over 2 is negative sine of pi over 2 plus 6 times pi over 2. So pi over, what's pi? How many degrees? 180, so pi over 2 is 90, and I want the y value. Which is 1, but it's negative. So negative 1 plus, that's 3 pi, right? And half of 6 times half pi is 3 pi. That's not my answer. I don't want to forget what I forgot. Last question, what do I still have to do? 1 over. That's supposed to be a 1. Alright. Other ones. Okay. Go to 3-4, but it's really like, it's just memorizing formulas. It's annoying, but I don't think it's difficult. I think there's a difference there. So there's really only, there's 6 derivatives. If you look at the back of that sheet I gave you, there's 6. There's really only 3. Like sine and cos inverse are the same derivative, except the one that starts with c is negative. You ready? I'm doing my thing.
I know.
Yes. So there's only 3 on the back, right? They're just listed twice, and then it starts with a c and sine. Like sine inverse and cosine inverse are the same, it's just cosine negative. secant and tan inverse are basic. No, secant and cosecant are basically the same. It's just one thing. So sine inverse is 1 over the square root of 1 minus x squared. Like 99% sure I have that right. Is that right? Is that what I wrote on the sheet? And then cosine is just the negative of that. Secant is 1 over, so every year I do this. It looks like that. People are like, why'd you put 1 times 1 in the formula? Does it look like 1? That's absolute value. And then cosecant is the same thing but negative. Remember, absolute value, whatever's in there, is going to automatically be positive. And then tan inverse is 1 over 1 plus x squared. That's like my favorite one. I mean, there's no root, right? It's the easiest one. And then cotan is just the negative of that. So those are the sheet I gave you. Again, I would do whatever you have to do, whether it's flashcards or Quizlet or just handwrite them until you get them. But there's going to be, it's a 10-question gateway. I'd say 3-ish of them will have one of those things that you have memorized. And if you don't have memorized, you're not going to get it. There's no way you can kind of fudge your way into that. So you got to memorize it. So let's look at some of the problems with them. It's really just like memorize the rule and then do chain rule. So the derivative of sine, so this is your big guy. That's your little guy. So then the derivative of sine inverse is 1 over 1 plus, in the rule it's x squared. But now we have a little guy in place of that x, so what am I going to put in this parentheses? 3x. And then what do I multiply by? It's just chain rule. So I multiply by the derivative of the little guy. So I'm going to multiply by 3. And then they would probably put that 3 on top, so it's like 3 over 1 plus 3x squared. But it's literally just memorize the rule and then don't forget the chain rule. I don't have a ton to explain, you just gotta get to them. Tan inverse is 1 over 1 plus whatever squared. In this case, what's the whatever? 2x squared. And then I always multiply by the derivative of that little guy, so I multiply by 4x.
I have a question.
Yeah.
For the first one, the derivative of inverse sine.
Did I forget the square root? I did.
And it's minus 3x.
This is what happens to you in the gateway if you don't memorize the rules. I just messed that one up. Stop me before I go do 2 more problems, man.
Do as I say, not as I do.
Yeah. So that's my sine inverse is 1 over the square root of 1 minus blah squared. What's the blah? 3x. Then you multiply by the derivative of the blah. So you put times 3 at the end, or you can just put like the 3 on top. My bad, thank you. I think I was like looking at tan while I was doing this. Who knows? I'm so excited for tan. I couldn't wait. And then number 3, so do we know what arc-seek is? So that's the same exact thing as if it said seek inverse. So this could be arctan, this could be arcsine. So there's just like 2 ways to write it. And then we follow the rule. So the secant rule is 1 over the absolute value of blah. What's blah? 5x. That's the square root of blah squared minus 1. But blah is 5x. Times the derivative of the blah. Times 5. And then you get that. Questions on those 3? That's really all. I mean, I can give you more of those, but it's the same thing. Like, just look up the rule, plug in, do the chain rule. 4 and 5, we just talked about simplifying here a little bit. And if it's a free response, you don't have to do this. Multiple choice they would have. I'm going to start with 5 first, because it just makes more sense to people. Is there any reason, is the absolute value providing anything to number 5? It's not doing anything, right? Because if I take an x and square it, doesn't it always be positive? Multiply by 2 is still positive. So this is basically to show you that you can just kind of work with them as though, in this situation, as though the absolute value sign is not there. You can cancel it. You can do whatever. Absolute value doesn't matter because squaring something makes it positive anyways. So it's like, hey, I want it to be really positive. Emphasize it. Positive. And then this one, you can kind of take things out. It's almost like a root. You can take things like that. Not quite like a root, but is the absolute value sign impacting the 3? Doesn't matter at all for the 3, right? So first of all, I can cross off that 3 and make that. With the x to the 3rd, 2 of those don't mean anything, right? 2 of those make, like x squared, the absolute value signs don't matter. Agree? So I can take an x squared out, and I can rewrite it like, the first step would look like this. So this is really the same as the absolute value of x to the 3rd, right? I just pulled out the x squared, that's going to be positive anyway, so that squared part does not need the absolute value signs. That x does, because that x could be positive or negative. But now that I've done this, I can cancel those and say it's 1 over the absolute value of x. And again, if you left it like it was originally, like that even, is a perfectly valid answer on a free response. Again, multiple choice, they would probably jump to that. I'm not going to worry about, I know you guys did, like restricting the domain and stuff last year. We're not going to worry too much about that. It is very, very rarely on the AP test. But let's look at like 6, 7, 8. So the hard part of these, I think, is like, you gotta know the units. So, arc sine is sine inverse. So your derivative would be sine inverse is 1 over the square root of blah squared plus 1. But in this case, the blah is just x.
It's 1 minus x.
1 minus x squared. 1 minus blah squared, and it's just x. I have to now plug in x. It's 1 over the square root of 1 minus the square root of 3 over 2 squared. So, what is the square root of 3 over 2 squared? It'd be 3/4, wouldn't it? Square the top and square the bottom. Alright, just keep working across here. What's 1 minus 3/4? It's a quarter. But that's still underneath the square root. So we're going to take the square root of the top and the bottom of that fraction. So isn't that 1 over a half? And then we don't divide fractions. We invert and multiply. So 1 times 2 is 2. So like you plug in and then you just kind of work through simplifying until you get to a standard number. I guess you don't have to really even circle these. Question on 6 then? Yeah. Oh, crap, what did I do?
Well, you're supposed to just evaluate the function,
That's stupid.
not find it.
What? My way is, my problem's better. I don't even care about these though. You don't, 6, 7, 8 or nothing, whatever. I want you to know how to do 1 through 1 through 16. 17 is through 17. So lately, and I've noticed this and I like it, you guys have been asking more questions. I think that, like, in my opinion, you going over questions at the beginning is just as valuable as, like, the teaching. Like, don't be afraid to ask. I don't mind if we spend a whole hour going through questions. Like, I'd rather that than you guys don't know what you're doing. So please keep. I like it. It's been getting more. It's getting harder. You guys are getting more comfortable with it. But keep coming. Remember,
Did you just say it out of nowhere?
so we have one lesson left tomorrow, but it's pretty straightforward. I don't think you guys will have trouble with it. And then a review, practice gateway. On Monday, test. Tuesday, Wednesday, Thursday. What?
I saw that. I was like,
You appreciated that I'll be gone? Or the
I appreciated that you told us that you warned us. Because now I can get the morning out of it. MOUR.
Okay.
That was scary. One half of my class.
That's right.
Actually, 2/3 of my class.
We'll
is
have no
for
more
band.
notes.
After band is
More
over.
time.
First 3 hours. And then
You guys just had band? You had band in math?
in the middle school.
Right. How'd that go?
Fun.
That was cool.
Played 2 notes.